Subtracting my polynomials. We're going to be adding and subtracting them. So, if we remember, we said our polynomials are just, it means many terms, right? It means we have a whole bunch of terms, 5, 6, 8, however many, right, that we want to have. And we have some, let's say, exponents like this, then I have more exponents, and then I have just regular old x, right? And then maybe we can have a regular old number just to say why not. So, we have a polynomial, okay? It has many terms. It has many terms. We know we can't add any further than this because our exponents are a little bit different, right? So in my notes, my first sentence says, like terms are terms that have the same what, okay? Let's say if I write negative 2x cubed, okay? This is a like term to 6x cubed. They're like terms because they have the same variable and they have the same exponent, okay? So, they are called like terms because they have the same variable and they have the same exponent. So it says here, like terms are terms that have the same, we could put right here, they have the same variable. Okay? Like terms have the same variable. And it does. We've seen it many times, right? And they're raised to the same what? You can say to the same power. You can say to the same exponent. We're referring to them both being cubed. Okay? They would be considered like terms, right? So when combining our like terms, the blank are added. Okay? If I told you to put these two cubed terms right here together, what we're adding or subtracting together, if this was positive like this, is we're adding our coefficient. Okay? So we're adding our coefficient. Okay. So if I do 6x cubed plus 2x cubed, 6 plus 2 gives me 8. Okay. And my variable with my exponent stays the same. Okay. My variable with the exponent stays the same. So I'm just going to put here, I'll change the color, my variable with exponent. It stays the same because we're only adding or subtracting them. Okay? We're only adding or subtracting them. Okay? So whenever we're adding, subtracting polynomials, what we're adding and subtracting are our coefficients, our variables staying the same. Okay? So we have an example there. We have 4x to the 5th power minus 10x to the 5th power. So it's subtraction, right? Remember, my coefficient is the only thing that I'm adding or subtracting. So I'm going to do 4 minus 10. That gives me negative 6. And then I know my variable with the exponent stays the same. Okay? That's it. That's us adding or subtracting our polynomials. Okay? Now, when we have a lot, sometimes it could get a little confusing. If it helps, you can line them up on top of each other. So on the bottom we have 6x squared, y cubed, z, plus 3x squared, y cubed, and z. Okay? It looks kind of crazy. So let's move this up a little bit right there. And I'm going to rewrite this on the side so we can see it a little better. Okay, so I have 6x cubed, or sorry, 6x squared, y cubed, and z. And we're adding 3x squared, y to the third, and z. Okay, so all of these are like terms. Okay, I have x's squared, I have y's that are cubed, and I have z's by themselves. Right? So all I need to do is add my coefficients together. If I know I don't have any number in front of a letter, that just means 1. Okay, that just means 1. So I'm going to add them. 6 plus 3 is 9. My variable and the exponent stays the same. And then I have 2 y's that are cubed. And then I have 2 z's. Okay? That's all that we're doing. That's all that we're doing. Okay? Adding and subtracting just our coefficients. Our variables stay the same. Please remember, only like terms with like terms. Okay? So, let's do some examples in the bottom. Okay? We have a few. We'll do some addition, and then we'll do some subtraction. All right. Whoa. Sorry, guys. Here. It says, when adding polynomial expressions, we combine something. Okay? When adding polynomial expressions, we combine just our like terms. Just our like terms. Okay? If you want, I'll put it here. We're combining like terms. That's it. It says you can underline, highlight, circle, however you'd like to differentiate your terms, you can do that. Okay, so we have something pretty crazy. We have negative a to the 4th power plus a cubed minus 2a squared minus 6a plus 5. And we're adding that together to 3a to the 4th power minus 5a cubed plus 7a squared minus a minus 9. Right? So you can do it like this and just go one by one, you know, do your a to the 4th power and then move on. If it's better for you to put them on top of each other and solve it like a column going up and down, do that. Okay? For now, we'll do it like this. The next one, we'll do it as a column. Okay? So I have negative a to the 4th power plus 3a to the 4th power. I know if I have just a letter, I have an imaginary 1 in front. So negative 1 plus 3 gives me 2. And then my variable, oops, my exponent is 4, Mr. Vignon. My variable and my exponent stay the same. If you want to scratch it out, you already did it. Whatever helps you go down the list. And then I have positive a cubed minus 5a cubed. 1 minus 5 is negative 4. So I'm going to put negative 4. A cubed. And I'm going to scratch it out because we already did it. Now moving on to my squares. Negative 2 plus 7. Negative 2 plus 7. That's positive 5. A squared Negative 6 plus negative 1. So negative 6 minus 1, that's negative 7. A. And then I have 5 minus 9. Okay, 5 minus 9, that gives me negative 4. So that's it. I added both sets together. I did it one by one. And I can't do anything else. I combine all of my like terms together, but I know if I have something that is squared and something that is cubed, I cannot combine them any further. Okay? You can add like that. Or if you prefer to add and line them up, you can do that as well. I'm going to do that with the one on the bottom. So we have 4t to the 4th power minus t cubed plus 5. And I'm going to line up, we're adding t to the 4th power minus, oops, minus 5t squared minus 2t. We get the gist of everything if you want to make sure. Okay? So all we gotta do is put it together. 4 times 1 gives me 5. T to the 4th power. I don't have any other cubed t's, so that one stays the same. Same with my square. And my regular old t. Plus 5. Okay? That's it. If you prefer to line them up like this, you can do that. It's up to you, however you'd like to solve for them. Just make sure we're combining only my like terms together. Okay? Only my like terms together. How do we feel so far? Pretty easy, kind of hard. So. So let's do one more addition, and then we'll do a few subtraction problems, and then you should be able to have time to work on the practice. Okay, so at the top I have minus 5w cubed, not cubed, to the 4th power plus 7w cubed plus 3w squared minus 2w plus 5, and we're adding it together, 3w to the 5th power plus 9w to the 4th power minus 3w cubed plus 6w squared minus 8w plus 2. Okay? So if you want to line them up, you can. I'm just going to start. I'm just going to go ahead and start going. Okay? I'm going to choose the largest exponent, which is right here. And I see I don't have anything to add it to on the other parentheses set. So I'm just going to write 3w to the 5th power. Okay? And then I'm going to go ahead and look at my 4s. I have negative 5 and I have positive 9. Okay? So negative 5 plus 9 gives me positive 4. W to the 4th power. I'm going to scratch those out because I already did it. And I'm going to work my way down from 5 to no exponent. I have positive 7 minus 3. That's give me positive 4. My variable and my exponent stays the same. Okay. Positive 3 plus 6, that gives me positive 9. W squared minus 2 minus 8. That gives me negative 10w. And then 5 plus 2 gives me positive 10. Okay? That's it. I added the polynomial together. This is what I have left. I don't have any more terms that are like that I can put together. That's it. Okay? So, let's go into subtracting. Okay? Subtracting a little bit more. So, when we're subtracting our polynomial sets, got a whole bunch of parentheses with a whole bunch of numbers, we need to make sure we distribute my negative, okay, my subtraction sign. Okay, to subtract polynomials, we need to distribute the subtraction or the negative. And we're going to distribute it to all the terms after the sign. So we distribute the negative to all the terms to the right of the sign. I don't have enough space there. To all the terms to the right. In the right parentheses. The second parenthesis. Okay? So we need to make sure we distribute that negative the whole way through the subtraction. Whenever we are subtracting, it is a lot easier if we just go ahead and do it as a column on top of each other. Okay? And I'll show you why. So I'm going to go ahead and distribute this negative to everything, and I'm going to rewrite it underneath the left side. So negative 8x cubed. Okay. And I have negative times negative, that's positive. 3x squared. Negative times negative is positive 2x. And then I have minus 9. Okay. The reason why I say it's a little easier to do subtraction like this is because if you look right here, okay, and you think about it, you're saying, well, I'm going to do negative x minus negative 3. Okay, this right here confuses a lot of people. So it's a lot easier to just distribute the minus or the negative to everything and write it on top and on bottom of each other. And then all we have to do is put them together. 2 minus 8, that gives me negative 6, and then my variable and my exponent stay the same. 6 plus 3 gives me 9. Negative x plus 2x gives me positive x, and 1 minus 9 gives me negative 8. So even though it says it's subtraction, there were some that we added because we had to. Okay? Because we had to. Okay? So please be careful whenever we are subtracting that if you don't do it like this, if you want to do it just from left to right, please be careful whenever you're subtracting a negative number, because minus a negative, it turns into a positive. Okay? Just want to make sure we're all on the same page there. Okay? So, let's see, we're almost done. We're almost done. So let's do something like this. It's a little longer. Hello. There we go. It's a little longer than the one we had. Okay, but we can do it together. So in subtraction, what I'm going to do, I'm going to go ahead and distribute the negative to everything on the second parentheses. Okay, I'm going to distribute it to everything, and I'm going to write it underneath the first one. So I have z to the 5th power, and it's going to be minus z to the 5th power. Oh. Okay, and then I have negative times negative that turns to a positive. So I'm going to do, here, I'll change the other way. Plus z to the 4th power. And I'll scratch them out so we can see that we're going through. And then we have minus z squared. Okay. And then we have minus 5z plus 1. Okay. I know it looks a little messy. I'm sorry. The board's acting up. So we'll just go with it. Okay. And now we're going to put them together. So to the 5th power, I have z minus z. Okay. If I put them together, that gives me 0, right? So I'm not going to write it. I'm going to go next to my 4s. Okay. So these cancel out right there. I have negative 3z to the 4th power plus z to the 4th power. Negative 3 plus 1 is negative 2. 2z to the 4th power. Okay. And I'm going to move on. Do I have anything to the 3rd power? I don't. Now I'm going to go to the 2nd power. I have 2 minus 1. 2 minus 1 is still 1. So I'm going to put plus z squared. And then afterwards, after I have 2, I have just 1. The only thing I have is minus 5z. And then I have negative 7 plus 1. Negative 7 plus 1 is negative 6. And that's it. That's me adding my polynomial. Okay? That's me adding and subtracting my polynomials. It said to subtract them, so I made sure to go ahead and distribute the negative or the subtraction to everything on the second parentheses. And then I just added them together. Okay? I added them together once the signs were correct. And I can't add any further because I have to the 4th power, the 2nd power,